Today we're going to get into solving inequalities. We're going to talk about polynomial functions and rational functions, the last two functions that we've talked about. But this time we're going to be solving inequalities. And I have to admit, this is one of my favorite sections of the whole course. It doesn't mean it's an easy section, but it's kind of interesting and it's pretty fun to do once you know how to do it. So for our first video, we're going to be talking about looking at a graph and deciding greater than or less than from a graph. In later videos, we will learn to do this algebraically from an equation. Okay, so starting with inequalities by graph. So let's say we're given this graph. Hopefully you know whether this is a polynomial or a rational expression. Think about that for a second and why you know it is. Okay, so this is a polynomial. I can tell because it is continuous on all numbers in a domain. Okay, all real numbers. Every number for x I can put in. If it was a rational function, there would be numbers for x that I couldn't put in because they would be in the denominator of the function, right? So I can tell from the graph that this is a polynomial. Another thing I can tell from the graph, since it's up and up, right, is that it is an even degree function. And I can also tell there are 1, 2, 3 maxes and mins, inflection points. So I know that it is at least degree 4. Probably it looks like degree 4, but it could also be degree 6 or 8. You know, it could be a higher degree that I just can't see the other parts. So those are things I know, and that's just a kind of a review thing since I'm looking at this graph. Another thing that I know for sure is that I have zeros here at -3, at 2, and at 5, right? So the first question you might be asked at in this section is, when does f of x equal 0? Okay, when does f of x equal 0? So you would have 3 answers to that question. When x equals -3, 2, and 5. Right? Those 3 numbers. And we do need to know those numbers for the other parts of the question. Another question you might be asked is f of x. When is f of x greater than 0? Okay, so when is it greater than 0? When you're looking at a graph, you are going to be looking at the graph that is above 0. Okay, so I'm highlighting the parts in the graph so that you can easily see, okay, the graph is greater than 0 here, the graph is greater than 0 here, and we are going to answer in interval notation. So we're starting over here in x, negative infinity, and we end at this -3, and since it's just greater than 0, that's why we use a parenthesis instead of a bracket. And then I have another part over here starting at 5, again, the parenthesis because it's only greater than, it's not equal to 0. So we don't want to bracket the 5 and include the 5. And we end at infinity there. Okay, so that would be f of x greater than or equal to 0. So the next thing you might be asked is, where is f of x greater than or equal to 0, right? Greater than or equal to 0, which you might think is almost the same as b, but there is a little bit more going on there because right here at 2, it is also equal to 0. So we still have the same initial interval, except, oops, talking and writing at the same time, dangerous, -3, okay. Right here we want to use a bracket because we want to include where the function equals 0. And then if we want to include just one number, how we do that in interval notation is bracket to bracket. Okay, so that's just saying we want to include the number 2 but nothing around it. And then we'll union that with 5 to infinity. So that's bracket 5 comma infinity. Okay, so that's where f of x is greater than or equal to 0. You also, of course, might be asked, can't erase that part, might be asked where f of x is less than 0. So if it was less than 0, That means that we are looking for below the x-axis. Where is the graph negative? Not the x values, really the y values. Where are they negative? So here you can see from my underlining, when it's less than 0, there's actually two intervals. We go from -3 over to 2, and then we don't want to include the 2 because that's where it equals 0. So we can't include the 2. So then we go 2 to 5. Okay, so from 2 over to 5. Notice that I'm never using the y values, okay? I've seen a few mistakes in this. People are answering y values for things when for everything you should be answering x values except for range, okay? Range is y values, but everything else is x values. If they specifically ask for the maximum or minimum value of a function, that is a single y value. But most of the time in intervals, they're asking for x values only. All right, and then our final part that they might ask is, where is this function less than or equal to 0, right? And in that case, we're starting with that bracket at -3, and we want to include the 2. So we don't really need to have 2 bracket and then 2 bracket because, the 2 is just part of the interval. So we would actually just have -3 to 5 bracket. Okay? So it's a nice visual way to do a problem and to see what's going on with inequalities. I think that's why I like it for this part.